I'm Andrea Falcone, and I'm going to talk to you about the Android developer option screen, and my subtitle is, what can those toggles do for me? So if you're familiar with that screen, there's a lot of toggles on there, and I'm going to walk through them and tell you how they can help you, what you can benefit from. So, cool. Like I said, my name is Andrea Falcone. I'm a software engineer. I work at Twitter. I've worked on all sorts of things while working at Twitter, except for Twitter itself. So I started at Crashlytics about 3.5 years ago. How many people are familiar with Crashlytics? Awesome. So I was there with Crashlytics before the acquisition by Twitter, and then I helped to build out Fabric with that team. And most recently, I've been working on Fastlane Tools, which is a build and release automation suite for Android and for iOS. Over my time at Crashlytics, Fabric, and Twitter, I've worked on a lot of different aspects of Android development. I've spent time working on the original Crashlytics for Android SDK, the Beta by Crashlytics Android app, as well as all kinds of tooling for Android developers, our Ant, Maven, Gradle, IntelliJ, Eclipse, all these different plugins that our team has built. I've spent time working on all of those as well. So, as I mentioned, I've done a lot of tooling work, but I'm going to let you in on a little secret. I've never really worked on an Android app. I have one, it's the Beta by Crashlytics app. It's not even in Google Play. So a little bit of an imposter here telling you about Android development, but I spend all of my time in tools for developers who make awesome apps like you guys. So the reason I proposed this talk is because I felt like I didn't know enough about the topic. And so before I had even written it, I proposed it and it got accepted. I was like, well, shit, I better start figuring this out. So that was my motivation, was really learning what these things can do for me and for other folks as well. So the developer options screen, probably most of you know how to get there. You go turn it on, tap the build number 17 times. This option shows up. There's a really cool shortcut that you can get available in the Play Store. So you can put this widget on your home screen and get directly into the developer options when you want to turn things on and off. As you'll see throughout the talk, some of these options do crazy and wild things to your screen. And it might be hard to get your way back to the developer options to turn things back off again when you're in a different language or a different layout, or there's colors flashing, things are going wild. So you want to be able to get back in there and undo the mess that you've done to your device. So there are tons and tons of developer options. The themes are basically generally around simulating behavior on your device that your users in the wild might be experiencing. Different device states, and also adding sort of additional avenues for debugging your app, getting your app to go through states that it doesn't naturally go through or doesn't go through that often, enabling you to do deeper debugging and solve issues more easily and faster. So these options cover the range from UI debugging, GPU monitoring, event log, extra event logging, and different kinds of simulation. There are over 40 of these options, and that number grows with every new release. Several were added in the end preview. You might have heard at the keynote yesterday. I'm not going to cover those new things today. There's even a patch to Marshmallow that added for 5X users the ability to change the coolness of the white screen on the device because people complained about it. So every new release of Android adds something new here, and occasionally they take some away, but it seems like things are just piling up on this option screen. So there's a lot of things that can be really confusing to know what is useful for you. So just going to cover a few of these. We could talk all day if I went through them one by one, and I'm sure you've got other things to get onto this afternoon. So they're not all going to be new to everyone here. I'm sure you've played with some of these before, but the goal is that you will learn something, take that back, and make your own apps way more awesome. So I'm going to start at the very top, and I promise I won't go one by one. But the very first option is Take Bug Report. And so what does that do? When you click on that, you're going to get a pop-up, and it does what it says. It's going to collect a crap load of information about your app, about the state of the device, and it takes several minutes for this to work. So you hit report on this dialog, and then you wait. You're like, is it doing anything? What's happening? You get a notification when it's done. When you tap on that notification, your email client is going to open with an attachment, and that's where your bug report is. That attachment is huge. It's about when I took the sample for this, it was 14 megs of text. It was 200,000 lines. I hope you can find what you need in there. It's all in there, but finding that part is the challenge. You can also capture a bug report using the ADB bug report command if you don't want to go into the developer options screen. So what's in there? What's in that monstrous text file that's going to help you? It's a series of running, basically, shell commands on the Linux that's running underneath. So you're going to see things like the uptime command, how long has the device been running for, statistics about memory performance, things that are currently in memory for every running process when that bug report is taken. There's also, it takes the dumpsys command, so that's going to give you information about everything that's happening on the system, including the view hierarchy for every active fragment in every app that's running on the device. It's a lot of information. Other things about IP tables, logs. There's about an hour of logcat is what the history gave me. So that's a long time. If a user in the wild is reporting a problem and they can't plug a USB cable into their device and get you the logcat that you're looking for, and they're somehow able to send you a monstrous text file, you could ask them to go in there, take a bug report, send it to you, and you could sort out from the logs that are on the device what's going on. So moving on to the next option, mocking device location is really useful for testing different kinds of mapping applications or anything else where your app is geo-aware. Pro tip, this is also really great for stealing those swarm mayorships from places you don't actually go. Back in the day when Foursquare gave out bonuses for people who were the mayor, definitely checked into a lot of places on my emulator. So when I first tried to use allow mock locations, I was really surprised that it was just a toggle. I was like, okay, nothing happened. I'm expecting to be able to maybe enter some coordinates here. Like, what is this doing? But it's just a toggle that says allow. So I was expecting more. It turns out that mocking locations on an emulator is really simple. You can use the location console in DDMS, or you can telnet into the emulator and use the geofix command. Unfortunately, neither of these work on real devices. So what you're left with is using the location manager's set test provider API inside of your application. The easiest way to do this is to call the method with a given location, and then you turn location off on the device. You enter airplane mode. That way you can be assured that your app is getting that one location that you set through this location manager test provider API. There's a number of other applications out there in the App Store that will do this for you, so you don't have to add this code into your own app if you don't want to. And it was a bit of a letdown that you couldn't just go in and enter your coordinates and set your device to be there. Newer versions of the Android OS have changed this option from being, the allow mock locations to actually being the set mock location app. So it's much more specific about how this actually works. You tell the OS, this is the app that's going to provide you with a mock location, but you're still using that same API. All right, the next option I want to talk about is the wait for debugger option. So this only becomes available when you've selected a debug application. So any applications that are able to be debugged on your device would be available in that select debug application list, and then you can choose to wait for debugger. And what that does is it makes the OS block on the selected application until the debugger attaches to it. This way you can set a breakpoint in onCreate, which is really important to debug startup processes of your activity. It's really helpful so that you can get into that onCreate method several times without having to restart your app in debug mode through Android Studio. So if you're running into crashes or problems that are happening in the very beginning of the startup of your app, by the time you turn the debugger or set the debugger on, your app has already started, has sort of passed that without this option. One thing to note is that when you change this option, that app is going to be restarted by the OS, so that can be started in this wait for debugger mode. So if you've got something going on with it already, you're going to have to restart the app to actually use this. An alternative to get the same type of behavior is to add a call for wait for debugger into your onCreate method, and just set a breakpoint just after that so that you can hit that breakpoint every time the debugger will wait for this code to start so that you can catch these bugs that are happening at the very beginning, the startup process of your app, without having to relaunch in Debug through Android Studio every time. Cool. The next option that I want to talk about is the show touches. And turning this on basically gives you a little white circle on screen that shows you where you're touching, just as it does what it says in the box. I really like this for presentations or doing screen recording where only the screen is being shown for things like a demo. It makes what the user sees more realistic instead of things just starting to happen on screen. So we'll take a look at 2 video captures here. And I took these from an actual device using the screen capture functionality in Android Studio, if you're not familiar with that. In the first capture, things are going to just start happening. So you don't know where to look, you don't know why that keyboard came up, what is making this scroll, who touched where. It did the same behavior in the second one with show touches turned on. So you can see where it's being tapped, you can see that the user is scrolling, just to give you the viewer, a sense of what is happening on the device that causes these interactions, or it causes these app behaviors to appear. It's not so much about debugging, but it's more about presentations or demos or getting your point across to investors or coworkers or QA or anyone else who's trying to understand what your app is doing, and you're not standing there showing them, I'm tapping on this and I did that. In a similar vein, but more technical, is the show pointer or pointer location developer option. If you're experiencing issues in your app where maybe the drag speed seems off, or you've got a doodle app and you're doodling here, but your drawing is coming out in a different place, anytime you want to know more information about what a user is doing, how they're interacting with your app, you can turn this on. Let's take a look at another quick video that I made. Cool. So what did we see there? So we turned it on. The first thing that we saw was the pointer location. So you're going to get crosshairs on your screen of the exact location where the user is touching at any given time. You're also getting this mouse trail-esque UI. And the color is going to change with the speed of the movement. And how that's done is the individual touch points that are recorded by the OS are drawn in red here, and a line is traced between them in blue. As the user changes speed, the color of the line changes. So the slower you go, the closer the touch points are able to be recorded together, the line is more red. The faster you're going, the bluer it is. This gives you an idea of speed and acceleration that a user would be interacting with your app via. The final thing, and sort of the information overload of the pointer location, is this overlay that appears at the very top. So you can see it back here. It's at the very top of it's cut off. Sad. Well, it's here. The very top of the screen has this overload of information. And so starting from the left, you're able to see the number of current touch points that are recorded or detected by the OS. The next value is the X and Y coordinates of the touch right now. These only appear while a touch is actively happening. I couldn't both touch my screen and take a screenshot of it at the same time. And so when you release the touch, you're left with dx and dy. That's the delta, the difference between where the touch started and where it ended in the x and the y location. The next value is the xv and the xv and the yv. That's the velocity. That's the speed that the user changed locations in, again, in the x and the y direction. Information overload. The final 2 values on the right are the pressure that's applied as well as the size of the touch. So capacitive touch screens, like the majority of our phones, that information isn't actually available, and so it's estimated for you by the OS how long you touched. Resistive touchscreens, though, are able to capture that type of information, and that might be useful for you in the app that you're creating. So you're able to see all of this information about how a user is interacting with an app, enabling you to debug problems that occur when maybe your math is off, you're not registering all the touches that you think you are, something along those lines. Great. So showing surface updates is a really cool a developer option. It's one of the ones I mentioned where you might not be able to navigate back to developer options all that quickly because your device is going crazy when this turns on. Well, what it's doing is it flashes the screen magenta every time that the UI updates. It can be a little hard to look at without getting a headache, but one practical application of this is in the Beta by Crashlytics app that I was working on. We noticed that a certain part of the screen was flashing pink all the time after all of the animations had stopped. Just the center of the screen was just flashing. Like, what is happening here? Well, it turns out that we did a fade transition from one view to another, and we hadn't properly set the gone or on invisible on the view despite having changed the alpha of it. So it was still on screen all the time, rendering, but we weren't able to tell that as a user because you couldn't see it. It wasn't doing anything visible, but it was still doing work. It was still updating the UI all the time. Whoops. So another thing I learned about this is that it's impossible to capture a video of show surface updates happening because the frame rate at which this thing is flashing pink all the time is faster than the frame rate that you can capture using the screen capture tools. So I encourage you to try this one on your own and then quickly turn it off before your eyes fall out. All right, the next option I want to talk about is show layout bounds. So this is another one of those options where crazy colors start happening on your screen. It lights up like a Christmas tree. So for each view on screen, you're going to see some different colors about it. The pink areas indicate the margins of the view, and then the blue and the red lines are your optical and your clip bounds. Optical bounds are the hard edges around an element, as opposed to the clip bounds, which include effects like drop shadow, sort of telling you the different places, the different parts of each element, where they are on screen and what they mean. You might want to turn this on if your app is not behaving in a way you're touching somewhere and it's not activating an element that you expect it to activate. Here it might be that the thing that's capturing the touch is actually the views that says printing. It's just that small little view, and I'm tapping on the row, and that's not activating the touch. Or it may be that you're trying to adjust the UI a bit, and you can't seem to add the right margin or padding to the right element to make it move in a certain way. Here you can see what items have the margin applied to them and which ones don't. So you can basically use this to understand why your UI in your app looks a certain way and make changes to it to get it to be what you're looking for. The next option that I want to talk about is Force RTL Layout Direction. So this toggle forces your device into right to left layout, even for languages that are not typically laid out from right to left. This is really great for testing internationalization of an app, not the localization of strings, but the internationalization of the layout. That one of the reasons that I've said you can't get back to developer options very quickly, if you turned your device into a language that you don't necessarily know how to read, something like Arabic or Hebrew, in order to test the right to left layout, now you've got to find your way back through the menus in order to turn things off. With this option, it just uses the language that the device is currently in, but it forces that right to left layout. So you can see that the buttons at the bottom of the screen have reversed their layout direction. The list items have reversed their icon and list item positioning. I looked through the Android OS, and most of the things are done correctly, except for this one thing I found at the top here, the debugging tag right in the developer options screen is unfortunately not internationalized correctly. Looks like they've used or left in some right and left padding instead of the start and end padding that they should be using, tisk tisk. But it was a really good test to see that this option was working and that it could find bugs pretty easily in your app just testing RTL layout without having to test other aspects of internationalization or localization. I'm not going to go into any more detail on that. There's lots of talks about RTL and localization out there for folks that are interested. All right, so let's talk about Debug GPU Overdraw. So get ready for some more awesome colors. So when you turn this on, you're going to get a variety of colors on screen. And overdraw occurs when the same place on the screen is drawn over multiple times while rendering by different views. The various colors indicate the severity of the overdraw. So if it's just plain, if it's white, the color of the background is transparent, then it hasn't been overdrawn more than just the one time it was needed to actually draw. Light blue is it has been overdrawn one time extra, and it goes all the way up through that dark red color. You have overdrawn that same place on screen 4 or more times. Overdraw is bad because it indicates waste, since you're doing work in drawing that the user doesn't benefit from. In this case, the background of some of those toggles is white, but it's on a white row. So why would I have drawn the background of the toggle on top of something else that was already the same color? You can fix these by using a hierarchy viewer to flatten out some of your layouts. Just push those views down into other layouts, or you can change the backgrounds to transparent so they're not doing any drawing. But it's a way to find places in your app where you're doing wasteful drawing, and you can get some performance improvements through doing less drawing in the app. Cool. The next option is simulate color space. And this became available in Lollipop. When you look at the name of it, it's not necessarily obvious to you what this does. But despite the confusing name, it's a simulator for different types of color blindness that can affect people. If you didn't know, there are several types of color blindness that different people have. And these examples are just some tests that if you had these types of color blindness, you wouldn't be able to differentiate the numbers that are drawn in those circular dots. You wouldn't be able to tell the blue from the yellow and the red from the green. And this can be a problem for people using your app if you're using color to differentiate different statuses or behaviors. So when you click on this option, you're presented with a dialog that has some pretty long sciencey words. I did have to go to Wikipedia and investigate what they all meant. That was a really, really fun trip. So when you turn them on, your device changes color. So I took some screenshots of my actual device with the colorful home screen with each of these turned on. What I found interesting is that I had done all the rest of my screenshots using the ADB screen capture tooling, but the color space simulation, that didn't come through. Every screenshot I took was still the normal color. So I had to actually get another device and take a screenshot of my phone so we can see they're sort of at a funny angle. You might see my fingers in the background. I don't know the reason behind that, but it was another one of those interesting things that I came upon in debugging and found sort of interesting that you may run into if you're trying to send off screenshots of your app to someone to see these modes. You're not going to be able to use those tools to do it. Great. All right, moving on to don't keep activities. So this setting simulates some unpredictable app lifecycle behavior that happens in the wild. When it's on, the device will terminate all activities when they're exited, as if the OS had killed them to reclaim memory. And what this does is more frequently and predictably exercise your onCreate and your save instance state methods, which are a huge source of crashes and bugs for app developers, because users going through those code paths aren't necessarily walking through the app in the way that you are using it while you're doing testing. So you take out your 5x. It's in a great clean state. You open up an app for the first time. You back in and out of a view, and you can't recreate these crashes or problems that your users are reporting. Well, their device may be running low on memory or just going through other lifecycle states that you as a developer aren't able to recreate in your quick testing. Works fine on my machine. So this is going to help you exercise those code paths more predictably so that you can find the bugs that your users are running into. So yeah, like I said, it's the onCreate methods, the save instance state methods, even backing out of activities and coming back into them without this setting on isn't going to exercise these methods, because backing out properly finishes activities, and so they don't have anything to be recreated from. The instance state isn't saved. Cool. Now for something wildly and completely different. It's not a developer option, but it's a neat trick that I came upon when I was doing some research for this talk. And it's that you can run ADB over Wi-Fi. So I thought it was really cool. I played around with it. I stood on the other side of the room and ran ADB commands with my phone over there, and I was really excited about it. So I decided to talk about it. Hope you like it too. So ADB typically operates over USB, as we all know. In order to use ADB over Wi-Fi, there's a few steps that you need to take. So first you have to connect your device via USB to initiate the process. A little bit of a bummer, but as long as both the device and the computer stay connected to the same network, you'll be able to continue debugging from that device no matter where it is, as long as it's on the network. Wire free. So you can get around this requirement to plug in to the USB, to initiate via USB if the device was rooted. And there are a different series of commands that you would run on the device itself to initiate that process. So then you start ADB in the TCP/IP mode, basically restarting it to connect over IP. And now you have to look up the IP address of your device on the network. And you can do that from settings, it's under about phone status, or you can acquire that IP address using the ADB shell. Either way. So once you've got that IP address, you call ADB connect on the IP address, and you're connected. You can unplug your wires, you can deploy apps, you can debug them, you can run all of your other ADB and ADB shell commands without having to be plugged in. So there are lots of random reasons why you would want to do that, but I think it's a really cool thing. You can be running a demo and have your test devices in the hands of your users, and from over here, deploy new software to them, or run actions on the device, put the app in doze mode from over there, so people with the device in their hand can walk through some simulation. Some of these are sort of contrived examples, but I think you can come up with something in your own workflow that this might be useful for. So there's a lot of other debugging resources out there beyond just the developer options. This is sort of just one place where you can go to get information. So some of these other ones are TraceView, which I think a few people have mentioned today. You can help you profile the performance of your app and allow you to understand what each thread is doing at any given moment. You can use DDMS, which is the Dalvik Debug Monitor Server. It's a tool that allows all kinds of useful information to be provided to you about the processes that are running, can forward port handling, and inspect memory allocations, can do a lot of cool things. And for emulators, there's a lot of other behaviors that you can force onto the device that you can't do on actual devices. ADB shell has a ton of commands that you can run in order to impact change on the device. You can change the locale. Like I said, you can go into doze mode. You can do a lot of things to your device using ADB shell to simulate behavior that a user in the wild would be potentially running into for testing. And hierarchy viewer, another one, allows you to see all of the view hierarchy. I think we've heard about it a few times this week as well. So there's other things out there, lots of other tools, apps that you can install to find out information about things that are happening on the device. It's about being curious and digging deeper and finding out more about what your app is doing out in the wild. So hopefully you've learned a few things from this talk. I don't encourage you to turn them all on at the same time. Like I said, weird things may happen to your device. But I hope you can use these to make your apps better, to track down those pesky bugs that are out there, make your apps faster, and overall improve your experience as an Android app developer. So, thank you guys. I don't know if anybody has questions, I can take them. I may not have any answers for them, but the question was for connecting to ADB over Wi-Fi. Do you have to reconnect every time you launch your app? No. Once you are connected, you are always connected to the ADB process. Yep. Good question. Any other questions? Oh, I can't say. Like, the question is, when you disconnect from Wi-Fi, will ADB debugging continue? No, you will have to reconnect, plug into USB, initiate ADB connect again with the like both at the same time. I'm not sure I understand the. I don't think so. I believe ADB is connected in TCP/IP mode only at that time, and when you break the Wi-Fi connection between the device and the computer that it's connected to, there's no connection happening. Yep. So you would have to. I've only ever tried it sort of in the like I'm no longer connected to USB, yeah, I'm free mode, and never the like now I want to be back wired mode. That's a really. I assume you have to restart ADB. Any other questions? Here. The question was, what do I find to be the most useful developer option? So as I mentioned, I don't work on the Twitter app itself, and so I can't answer that question in particular. But I think that the pink flashing one that now I can't remember the name of, the show updates is the best, because that is a source of problems that I've run into, that like something is still running. The performance is sluggish on the device, and I don't understand why. What is happening right now that I'm not seeing as a user of the app? So I think that one's really great. Cool. All right. More in the back. Cool. Thanks, guys.